So in this case, we can see that the length is 3 times the width. And I like the way you put that. Notice that they've split it up. They've given you the length, they put some words in between, and then they've said it's triple the width. They do that so that you have to kind of connect the dots a little bit. And then finally, what else does it give you? Another piece of information that would be great. Yes? The area of the pool. So that's another very, very important piece of the puzzle. Now, what are we thinking? If they give us the area of the pool, what formula do you think that we're going to need to use or utilize at some point? What do you think, Oscar?
A times h divided by 2.
Nice. Now I'm gonna. It sounds like you do the area of a triangle, right? Because you divide it by 2. So we could see here we have a triangle here. We have a triangle down at the bottom. So here's a triangle. There's a triangle. Now, mind you, if we put those two together, what's the shape of the actual pool? Oscar? Rectangle. So we can actually, while you could do that, that's not going to hurt anything. We could use half of this area, and we can use that formula. You're going to come out in the same spot as everyone else. Let's maybe work with the rectangle just to eliminate the fraction right off the top. So if we use the area of a rectangle, what would that be? Instead of the area of a triangle, what would that be?
E equals length times width.
Awesome. Okay, so once again though, using the triangle area formula, that's going to work just as well, just cause you one extra step. Okay, not a big deal. All right, now, can I sub in any information into that equation? What information do I know in this particular scenario? Awesome, what's one thing I know about this equation?
You know that the length, the length.
Yeah.
3 times longer than the width, then you do like 3x equals.
Love it. So if the length is triple the width, he's saying maybe use x as the width. So we could say x equals the width. And he says, we'll make the length 3x, right? Because it's 3 times the width. And then the width we have to include as well. So now we have another x there as well. Nicely done. What else do we know here? What else do we know? Yes?
The area.
The area. What is the area? The area.
192 meters squared.
Awesome. So folks, checking this out, I've got an equation to work with. Noticing that I've got 2 variables here. What can I do on the right side to simplify this, to get rid of the bracket there? Jordan?
You can put them together so you get like 3x squared.
Awesome. Nicely done. So I know that 3 times x squared equals 192. What can I do to get x by itself, folks? What can I do? Seeing about 6 of the same hands quite a bit. Any new takers here? Any new takers? Any new? Almost have our variable term by itself? Well, we've got the term by itself. How do I get rid of the coefficient? What's going to happen? What's going to happen? Yes, sir?
You'd have to divide 192 by 3.
Awesome. So we're going to divide these guys out. What am I left with when I do that, folks? What am I left with? Anthony?
64.
64 equals x squared. Nicely done. Now, if I know that x squared is equal to 64, check this out, folks. If x squared is equal to 64, look at this. Easiest way to show you that, there's a square. I know that x squared, x times x, equals 64. My question is, what's x equal to then? If x times x is 64, that's what x squared is. What is x equal to here? Megan? It is equal to 8. Nicely done. So we know that this is equal to 8. How could I do that in my calculator? For those people who are like, yeah, I know that 8 times 8 is 64. What would I do in my calculator to go from this number down to that number? What would I do?
You'd square it 64.
Awesome. If I square root it, remember square rooting will get you the original number that was used to be squared. Okay, it's the opposite operation of squaring a number. All right, so we know that x is going to be equal to 8. Awesome. So, where does that put us, folks? I'm going to give you a second for a couple people there. They're looking at it. They're going, yeah, this is great. Am I done part A? Is that what part A wanted me to do? Is that what it wanted me to do? What do you think? Lots of same hands. I know it's a Tuesday after a long, long, long weekend. Megan again?
You have to find the length, which is 3 times the width.
Awesome. So thinking about this for a second, folks, if I go over, I'm going to go to a brand new screen. Here's my pool. We know what the width is. The width is 8, but the length was 3 times the width. So in this case, what would be my length? Knowing that my length is 3 times the width. What do you think there? I think I saw Josh. What are you thinking? Nicely done. So essentially, if it's 3 times the width, I'm going to get my 24. So I have a length of 24. That's awesome. What was the question asking us, though? What did the question ask us about this particular question? We saw a cat. The cat doesn't come in yet, remembering that. What was the question asking us? Josh, again.
The floor swims across the diagonal and like back in. How far does she travel?
Ah, nice. So how far does she travel if she swims diagonally across the pool? Do we have that information here? Do we have the information that we need? What do you think, Jordan?
No, but we have like what we need to figure it out.
Nicely done. If I do one of these guys, if this is her path diagonally, what immediately jumps out at you? Notice I have my 2 side lengths. What is this doing to us? What's this telling us here? What do you think? I don't want to have to start picking on people, but what do you think? What do you think? What do you... Oh, I saw somebody faked back there. I saw it. He went like this, and then he went and scratched his eyebrow. That's a horrible fake. Yes, sir. Mr. Graham.
You notice that it divides the rectangle into 2 triangles?
Nicely done. Divides it into 2 triangles. Now, that could help. So I could do one of these even, and I bet you if I do this, it might help some people out a little bit. Okay, so it's like 2 triangles. That's definitely good. What do you think, Hannah?
You need to find the length of the hypotenuse, and you have what you need to do that.
Say that word again. The length of the what?
The hypotenuse.
The hypotenuse. So what's this angle over here, folks? What's that angle? Right there. Yes, sir. 90 degrees. We would assume, in this case, it did say the pool was rectangular. So that guarantees us that all the corners are in 90-degree angles. So automatically, if I want to find the hypotenuse, what can I use? I think we did this on like the 2nd day of school when we did a problem. Remember the taco cart problem we did, the video? We did this. We haven't seen this much since. What is it, Hannah, again?
A squared plus b squared equals c squared.
Awesome. Pythagorean Theorem can help us out with this. So this is like going way back. And we can go a squared plus b squared equals c squared. So my question is, what's a, what's b, and what's c in this case? For those people who haven't seen this in a long time or they're not confident or comfortable with it, what's a, what's b, what's c? Hassan?
A's 8 squared, B's 24 squared.
Awesome. So a would be 8, and we're going to square it. B would be 24. We're going to square it. Now, here's the problem, though. This is what I was thinking. I wanted this to be A and I wanted that to be B. Is that cool? Can I do that?
Yeah.
I'm allowed to do that. How about this, though? What if I did? I want this to be A and I want this to be B. Is that cool? Can I do that? Graham?
It would be, but you'd have to rearrange the formula so it'd be b plus c equals a.
I like it. So according to our equation here, not good. If I rearrange the variables in the equation, right, to suit what I'm doing, that would work. So let's try to avoid that. I'm going to go back to A and B. Our hypotenuse is always C, assuming C is by itself on the equation. Okay? So let's pop these guys in. Let's see what we get. I've got 8 squared. I've got 24 squared equals C squared. So let's do some quick math. I know, Anthony, it's been a long weekend there, buddy, but what's 8 squared?
8 squared
Nicely done. Now, I'm not going to ask anyone in particular, but what's 24 squared going to be? Now, let's think for a second. What's 20 squared? Does anyone know what 20 squared is? What is 20 squared? What is 20 squared? Yes, sir. 400. So we know it's got to be bigger than that. What would 24 squared be? What do you think, Anthony?
It would be 576.
Wow, I like it. Good stuff, buddy. No calculator there at all. Nicely done. So we knew it had to be bigger. We knew it had to be bigger than 400. In this case, quite a bit bigger. How about when we put those two guys together, 576 and 64? 576 and 64. I see the 4 and the 6 are going to go to give us a 0. That's nice. Who wants to give it a shot? I see lots of people doing it in their head. I like it. What are you thinking, Oscar?
640.
Everybody good 640? Everybody confident there?
Yeah.
We good there? Feeling pretty good? Right? So I got my 500. If I take my 70 plus 30, that's 600. Plus another 30. Plus, yep, that's going to give us 640. Nicely done. And finally, how do I get my c squared by itself? I got c squared equals 640. Remembering, this is what it looks like. Here's 640. That's x squared. What is x equal to in this case? What do you think? What's it going to be? Yes, sir.
Don't you have to square root it?
Awesome. What do you get when you square root?
25.3.
Say it again.
25.3.
25.3? We all good with that, folks? Awesome stuff. So that means that this diagonal must be 25.3 as well. So now, my last question for you is this. Am I done the question? Does this answer the question? If I just put, therefore, the diagonal is 25.3 meters, am I done? Is this good? Josh's on fire today. What do you think?
Because she went back, so you have to multiply by 2.
Awesome. So one way is 25.3. Going all the way back is going to add another 25.3. So therefore, she swam a total of how much, folks? What is it? 50.6 meters. Nicely done, folks.